Welcome back everyone to this Python certification training course. So this is a lecture on Python operators. So what exactly we're going to cover in this video is that we will first of all understand each of these operators in detail. After that, we'll work with each of these operators on the Jupyter notebook, right? Then we'll see the chaining in the operators, right? So now let's get started, guys. So first of all, when we understand operators, these are the types of symbols which are used for performing operations on one or more variables or values are called as operators, right? So some of the symbols like equals to, less than, or greater than, or the combination symbols that we use here, right? And whatever the variables or values that we are talking about, that are called as operands, right? So now the types of operators that we have here is, guys, first and foremost we have arithmetic operators where we perform the arithmetic operations, right? Then comes the relational operators where we find the relations in the other operands, right? So then comes the assignment operators. Then we have logical operators, membership operators, identity operators, and the bitwise operators. Now let's proceed forward and discuss each one of them briefly. So guys, first and foremost, when we talk about the arithmetic operators, as I said, these operators include all the basic mathematical operations, right? Now, guys, these all basic mathematical operations includes addition, subtraction, multiplication, division, modulus, floor division, as well as the exponentiation, right? So what exactly happens in addition? You all know that, right? It adds the values on the either side of the operator. Similarly, for the subtraction, you guys must be knowing, right? And the multiplication, it multiply the two values. Division, divide the two values. And modulus basically divides and it returns the values of your remainder, right? Whatever the two values that you will divide, let's say 2 by 3, and it will actually return the remainder of those of those two values, right? In case of floor division, guys, it divides and returns the integer value of the quotient, right? It dumps the digits after the decimals. So I'll show you as we proceed further towards our Jupyter notebook. And guys, in case of exponentiation, you guys must be aware that it raises the first number to the power of the second. So let's say if I have, so if we use asterisk sign, right? You must be seeing here in the braces, we have two asterisk signs, right? Let's say I have done 2 star star 2. So it is basically 2 is the power of 2. If I would have done 2 star star asterisk, I mean 4, so it would have considered it as 2 to the power 4, right? So that is how it works in arithmetic operators. So now when we proceed further, we have something called as relational operators. So these operators are basically used for comparing between two values or variables, or we can call them as operands, right? So what exactly it does is it finds which operand is greater or lesser or equal or even a combination of two, right? Then in this we have the less than operator, where it compares that whether that operand is less than the other operand or not, is it equal to the other operand or not, or is it greater to the other operand or not, and then greater than or equal to, right? Then less than or equal to, and then comes not equal to, right? Then the other operator that we have here is the assignment operator, guys. So assignment operators are basically used for assigning value to a variable. All right, it may manipulate the value by a factor before assigning it, right? In this, we have 8 assignment operators. One is the assign operator, which assigns the value to your current expressions on the left side, right? And then comes the add and assign. It basically adds the value on the other side and assigns it to the expressions on the left. Then comes the add and assign value. Basically, it adds the values on the either side, any of the side, and assigns it to the left side, right? And then comes the subtract and assign. Similarly, it subtracts the value on the right from the value on the left. Similarly, it goes for subtract and assign. Basically, it subtracts the value on the right from the value on the left. And guys, then comes the subtract and assign. So basically, it subtracts the value on the right from the value on the left. Then it assigns it to the expression on the left, right? And further, we have divide and assign. Similarly, it divides the value on the left by 1 on the right, right? Then it assigns it to the expression on the left again, right? Similarly, for multiply and assign, it multiplies the value on the either sides. And comes the modulus and assign. So guys, it performs modulus on the values on either side. Then it assigns it to the expression on the left, right? Then comes the exponent and assign. So it performs the exponentials on the value, right? As I said, on the either side. Then again it assigns it to the expression on the left. Then comes the float divide and assign, I mean, right? It performs float division on the values on the either side, and then again it assigns it to the expressions on the left. Right, guys? So we'll see these concepts as we move forward in the Jupyter notebook. So as of now, we are just briefing them up a little bit, right? All of these operators. Then guys, we have Python logical operators. So these are conjunctions that you can use for combining more than one condition. In this, we have three logical operators, which are called as or, and not, right? So these are coming under the Python operators. So and is used when whenever the conditions on both the sides of the operator are true, then a whole of the expression or the condition will become true, right? If the both side of conditions are true, then only the conditions in and will will be considered as a true condition. Otherwise, either of the condition is false, then it will take whole of the condition as false. And guys, in the case of OR operators, if any of the condition is true, then it will give out the whole condition as true itself. Let's say if I would have written 3 is greater than 5, then of course it will be false, right? And I would have used OR condition in between, OR operator, and then I would have said 3 is greater than 5 or 5 is greater than 3. You see, 5 is greater than 3 is true and 3 is greater than 5 is false, right? But here we have one true condition, right? So it will give the whole condition as true, right? And in case of not operator, basically guys, this inverts the Boolean value of an expression. Let's say I have written 1 is equals to 1. So of course it will be true. If I just write the condition as not, not Boolean expression, right? Not not 1 equals to 1, then it will actually invert the whole Boolean expression. It will print out false for you, right, guys? So this is what this is just a brief introduction to all of this. Don't worry, we'll as we proceed further, we will discuss all of these concepts in our Jupyter notebook, right, guys? Now guys, the next operator that we have is the membership operators. So these operators are to assess whether a value is a member of a sequence or not, right? So in here the sequence can be a list also, a string also, or even tuple, right? We have two membership Python operators which are called as in and not in. So in case of in, it checks whether a value is a member of a sequence, right? And in case of not in, it unlike in this not in operator checks if a value is not a member of a sequence, right? So we'll proceed further and use all of them in the Jupyter notebook, but right now we have other operators which are Python identity operators. So what exactly happens in here is it tests whether your operands share an identity or not. So in this we have two identity operators which are called as is and is not. In case of is, what condition it demands is that if two operands have the same identity, it will return true for you. Otherwise, of course, it is going to return false, right? Let's take let's say I have an integer as 20, right? But it is not same as 21, right? So it will return false for you. Also, if you take a string as 20 and another string as 20, right? Then of course they will be same. Then of course it will return out true for you, right? So let's say if I would have taken a 7 with single quotes and 7 with double quotes, here also it has the same identity. It is only a string, right, with the same value, right? So of course again it comes out to be true for us, right? Only differences here is the quotes. That does not make a difference, right? So in case of is not, let's say I have taken an integer as integer value as 29. Now I have another value as the string, right, which is 29 as a string inside the double quotes. So what I will do is here I will write 29 as my integer is not 29 string, right? Then of course it will print out for you that yes, 29 integer is not 29 string, right? So it will print out true for you, right? Don't worry, if you have not understood the concept right now, we'll discuss about this in the Jupyter notebook, right? Now guys, the last operator that we have here is the Python bitwise operators. So basically it includes all the binary operations in it. So we have the binary AND operators, then comes the binary OR operators, and then comes the binary XOR, binary ones complement, and the binary left shift, and then the binary right shift. Right. So what exactly happens in binary AND operators, that it performs bit by bit AND operation on the two values, right? And in case of binary OR, and it performs bit by bit OR operations on the two values. And similarly in case of XOR, it performs, and similarly in case of binary XOR, it performs bit by bit XOR, or we can say exclusive OR on the two values. It returns the ones complement of a number's binary, right? And it basically flips the bits, right? I'll tell you exactly how it's going to work as we proceed further in the Jupyter notebook. And in case of binary left shift, it shifts the value of the left operand, the number of places to the left that the right operand specifies, right? In case of binary right shift, it basically shifts the value of the left operand, the number of places to the right that the right operand specifies, right? So guys, these are all the operators which we're going to cover in the next lecture. But before moving on to the next lecture, there is a small concept which you all must be aware about, which we have actually studied in our school times, that is about the binary numbers, right? So keep one thing in mind. In case of binary numbers, we're going to take an imaginary scales, and we usually consider numbers as 0 and 1 in the binary, right? We are going to take this imaginary scale 16, 8, 4, 2, 1. These are the last four digits, right? It can go up to 32, 64, right? So let's take an example of 9, guys. So how should we represent 9 here? So what exactly will happen? We'll take this imaginary scale 1, 2, 4, 8, 16, right? And then 9 we have number here, right? So what I will do is that wherever it is positive, there I will put 1, right? So here 8, we have 8, right? Then I will put 1 in place, like down the 8, and then we have 1, right? Then I'll put 1 in down of 1, right? That is 8 plus 1 is 9, so 1 and 1 here, and the rest of the values will be 0, 0, 1, 0, 0, 1, right? So that is how we will represent 9. Similarly, in case of let's say 7, how we would have represented 7? So 4 plus 2 plus 1 is equals to 7, right? So what will happen? We will keep them 0, right? And this will be 1, 1, 1, triple 1, right? Similarly, let's say I wanted to represent 20. So 16 plus 4 is 20, basically, right? So what I'll do is that I'll keep this one and rest of the values as 0, right? Rest of the scale as 0. So 1, 0, 1, 0, 0, right? That comes out to be binary number for 20. So that is how we're going to work in the coming lectures. Alright guys, so this is just a normal concept that I want to share with you guys, just to clear out the basics.